All right, so let's talk about the mole. And we're not talking about the moles that you find on your skin or the moles that lit up your mom's garden. We're actually talking about the moles used in chemistry. We can also shorten the MOLE to MOL, which we're going to do from now on. And that is a SI-based unit used to measure the amount of a substance. And what does that actually mean? So actually, Avogadro, which is a chemist back in the early 1900s, he did many experiments with the element carbon. And he actually found that carbon-12, meaning carbon with 6 protons and 6 neutrons, if he had 6.02 times 10 to the 23rd particles of C12, they actually happen to be 12 grams, which is amazing because these two numbers are the same. And I'll show you why that's so amazing in just a second. If you actually go a little bit further with this, with more experiments, he actually discovered with that knowledge that these numbers, these atomic masses that we found on the periodic table, which is the average atomic mass of the particles, of those isotopes, are actually, if we have a mole of each substance, or 6.02 times 10 to the 23rd of each atom, that number is actually the mass that it has. So if we had a mole of potassium atoms, they would be 39.09383 grams. So that number actually is AMU and grams, which is awesome. So if we go back to this number and actually take a look at this number, we have 6.02 with lots of zeros behind it. That number is enormous. This hopefully gives you an idea of how big this number actually is. If we had a mole of marbles, it would actually cover the Earth with a depth of 4 miles. That is insane. That's huge. That just hopefully gives you an understanding of how big this number actually is, which then in turn should give you an understanding of how tiny the atom is. If only 12 grams of carbon is this many atoms, carbon atoms, which just shows you how tiny carbon atoms actually are, which is amazing. Okay, so let's actually put this number to use. So we understand the word dozen, and the mole and dozen are actually the same kind of concept. If we have 3.5 dozen roses, how many roses do we have? Well, we know in 1 dozen we have 12 roses. So let's use this information. So let's put it 3.5 dozen roses. And down here I'm making basically a ratio. Down here I'm going to have to put roses, because just like in dozen roses, because just like in math, if something's at the top of the ratio and the bottom of the ratio, they can cross out. So we know we have, in 1 dozen roses, we have 12 roses. So these units can cross out because one's on top and one's on bottom. We're left with roses. Great. 3.5 times 12 is 42 roses. So we know that 3.5 dozen roses is 42 roses. Okay, fair enough. Let's go into and start using the word mole. So let's say instead of 3.5 dozen roses, let's say we have 2.5 moles of roses. How many roses do we have? Well, let's do it again. So we say 2.5 moles of roses. 1 mole of roses is 6.02 times 10 to the 23rd roses, right? Because 1 mole equals that many roses. That unit can cross out. We're left with roses. If we multiply this number together, 2.5 times 6.02 times 10 to the 23rd, we get 1.505 times 10 to the 24th roses. It's a lot of roses. Let's start using this number, the moles, when we're dealing with molecules and atoms. This is when you're going to see it most. So let's say we have 9.03 times 10 to the 24th molecules of water particles. How many moles of water do we have? Well, it's kind of the same thing. So we're going to say 9.03 times 10 to the 24th molecules of water. We know that we have 1 mole of water is 6.02 times 10 to the 23rd molecules. Right? So we're going to cross out molecules, because one's on top, one's on bottom. We're left with moles. This actually gives me 1.5 moles of water. An easier way to write this rather than having that whole long number. That's my answer. Now the next question is, how many moles of hydrogen atoms do I have? Well, I know I have 1.5 moles of water, but if we look at water, it's H2O, so I have twice as many hydrogen atoms as I do molecules of water. So I could just simply multiply this number by 2. So 1.5 times 2 is 3. I have 3 moles of hydrogen atoms. in 9.03 times 10 to the 24th molecules of water. So this is just the beginning of using the moles, but hopefully you understand where the mole comes from and what it actually means and how we can use it in the future.